Now we're going to move into our last chapter of the semester, which is covering statistics. And with this, understand that statistics is a fairly broad topic that we're only going to be seeing the real tip of the iceberg for, as it were. Though what we did in chapter 11 actually was a lot of statistics, we just didn't really call it that. Here we're going to be looking at some of the basic notations that you can work with stats, as well as some of the fundamental computations to consider as well. And to begin, we're just going to set some notation that when we talk about statistics, what we're broadly talking about as a textbook definition is the science of collecting, organizing, analyzing, and interpreting data to make decisions, where the data is that set of info that we're collecting to work with, whatever it is that we're getting from our observations, counts, measurements, or responses, however we're drawing things, data is what we're drawing. And I think it's really important that even though here we kind of break statistics off into two categories as descriptive, where for descriptive stats we're looking at observations and presentations of data, things like just number sets, graphs, pictures, whatever you have for presenting the information, and inferential, where for inferential stats we're talking about making the actual interpretations off of them. Really, the big thing to hear when you're hearing that definition is that last word there, decisions. Because statistics is at its heart an interpretive science. It's not just about presenting information, it's about using that information to try and say something. Whenever we're starting out with this class in my actual stats classes, I'd like to tell them the joke about a mathematician, an engineer, and a statistician sitting in a bar, where someone comes up to them and asks, what's 2 plus 2? The mathematician looks a little bit confused and insulted and says, well, it's 4. The engineer, not wanting to be fooled, wanting to be very careful, gets out a pen and paper, maybe even a calculator, crunches numbers for a little while and says, it's 3.999. If you want to be sure, it's 4. The statistician, meanwhile, looks over, looks back, takes a quick drink and says, well, what do you want it to be? So it's important to understand here that when we're talking about stats, we're always talking in terms of that goal, that interpretation that we're building towards. So let's take a quick look at an example here to kind of see how these two things break off, even though really they go together. Here we're told that a study of 300 Wall Street analysts found that 44% incorrectly forecasted high-tech earnings in a recent year, indicating that predicting the stock market is difficult even for the pros. What we want to do here is see how descriptive and inferential statistics are used. So for this, the descriptive statistics here is just the numbers that we're looking at. The descriptive stats would consist of just those values. The 44% incorrect, while the inferential stats would be the conclusion that they're used for, the conclusion that is drawn from them. That is, that predictions are hard. But for one, I think it's really vital that you get from this, these two, even though we're dichotomizing them, work together. As when you're making a description of something, it's kind of impossible to not have a level of implication coming with it. There's no such thing really as a truly neutral presentation of a number, even something like that. And when you're trying to draw some sort of conclusion, you want the conclusion you're drawing to seem well argued, to have lots of evidence for it. And that's where those descriptions come into play, is having good numbers that you can plug in there to show someone, hey, this is why I'm saying what I'm saying here. This is why I'm saying that predictions are difficult, because 44% got them wrong. That said, that inferential statistics used there, it's a matter of what you want to see. If you're a more optimistic stockbroker, a more optimistic investor, maybe you're more prone to gambling, you might say, hey, 44% got it wrong, but that means 56% got it right. And a lot of people are happy to make bets based on something that's better than a coin flip. So it's really just a matter of what you're trying to say and what you're looking for when it comes to what that interpretation ends up being, which can lead to a lot of ambiguity that we're going to see more of later on in this section.